Chemical equilibrium means the branch of physical chemistry deals with favorable condition for conducting a reaction. For conducting a chemical reaction. Right. Now, before going to discussing about favorable condition for the reaction and all, first we try to understand what is reaction, what are the types of reaction. Okay, the chemical reaction means first we try to understand the chemical reaction. Chemical reaction you know, the process of reactants convert into products is known as chemical reaction. The process of reactants converted into products. The process of reactants converted into products is known as chemical reaction. Generally, there is a two types of changes in our surrounding. Some are physical changes, some are chemical changes. Here, chemical change is a permanent change. That means in the reaction, the substances are converted into initial substances are converted into new products. That means reactants are converted into new products. So, in a chemical reaction, reactants and products will be reactants and products. Reactants convert into new substances are called products. What are the reactants here? Reactants means the initial substance participates in a reaction. The initial substances participate in a reaction. The initial substance participates in reaction are called reactants. Right. Similarly, what is meant by products? The final substances, the final new substances formed in a reaction is there, no? Those are called products. The final new substances formed in a reaction are called products. Right? So reactants means the initial substance participate in a reaction are called reactants. The reactants convert into products is known as chemical reaction. The new substances formed in a reaction are called products. Clear? Now, a chemical reaction gives every information about the reaction expected time of a completion. Here you know that equation we represent the entire chemical process, we represent in the form of a small shorthand notation. That shorthand notation is nothing but what? Chemical equation. Chemical equation. That chemical equation gives information about which substance participate in the reaction, which substances are formed during the reaction, and how much time is expected to be complete the reaction. That means some reactions are completed, some are not completed, that continuously keep on going. That means based on the completion of the reaction, the chemical reactions are two types. What are they? Means reversible reactions and irreversible reactions. Chemical reactions are two types. Chemical reactions are two types: reversible reaction and irreversible reactions. Clear, my dears? Now, chemical reactions are two types. Chemical reactions are two types. One is irreversible reaction, another one is reversible reaction. Reversible, irreversible. Irreversible, irreversible reactions. Another type of reactions are nothing but reversible reactions. Let us discuss what is a reversible reaction. The first point, the reaction which proceed in only one direction, unidirectional. The reaction takes place in one direction. One direction. Okay, that is nothing but what? Unidirectional. Unidirectional. That means simply the reactants convert into product here. Once products are formed, the products never can be reactant back. That is the meaning of unidirectional or one direction. Okay, now second point, irreversible reactions carried out carried out in open vessel. Irreversible reaction. Irreversible reactions are carried out or performed in open vessel. Irreversible reactions are carried out in open vessel. For example, evaporation of water, thermal decomposition of calcium carbonate. It is a very important example. Suppose here it is an open vessel. This is an open vessel. Here I want to heat the calcium carbonate. Calcium carbonate crystals are heated here in the open vessel. Okay. So calcium carbonate crystals heated in the open vessel. What is your observation? A calcium carbonate CaCO3, it is nothing but limestone, on heating in open vessel, the CaCO3 is decomposed into CaO plus CO2. Here in this reaction, calcium carbonate decomposed and it produced calcium oxide and carbon dioxide. Carbon dioxide is obtained in which state? Gaseous state, so that gas are escaped from reaction medium. The gas is formed here, that is escaped from the reaction medium, so that the products never can be reacted back. Clear? So thermal decomposition of calcium carbonate is an example for irreversible reaction. Similarly, you can take one more example, means instead of calcium carbonate, you may take potassium chloride, KClO3. On thermal decomposition, it produces 2 KCl plus 3 moles of oxygen, 3O2. Here also oxygen obtained as a byproduct. The oxygen gas escapes from the reaction medium, so that it is an irreversible reaction. Okay. Next, coming to the next point, one more example for this. Even neutralization reaction, you know, the neutralization reactions, precipitate reaction, these are also example for what? Irreversible reaction. Precipitate reactions is also irreversible in nature. Example, AgNO3 plus NaCl gives rise to AgCl. It is a white color precipitate, and NaNO3, sodium nitrate, is obtained. Once precipitate is formed, reaction completed. Once precipitate is formed, means reaction completed. It is white color precipitate, white PPT. PPT means precipitate, an insoluble substance formed in a reaction. Similarly, one more example for this, BaCl Cl2 barium chloride and treated with sulfuric acid gives rise to the product is formed BaSO4 plus 2HCl. This is also example for what? Precipitate reaction. BaSO4 it is an BaSO4 is an white color precipitate, white PPT. So look that any precipitate reaction is formed. The precipitate reactions are example for irreversible reactions. Once precipitate out, the reaction completed. The products never can be reacted back. Clear? Similarly, neutralization reactions. Neutralization reaction also example for irreversible reactions. Neutralization reactions. Neutralization reactions are example for irreversible reactions. Irreversible reaction. You know, neutralization reaction means a reaction between acid and base to produce salt and water. Simple example, HCl on reaction with sodium hydroxide, it is a base, gives rise to NaCl, salt is obtained and water is obtained. This reaction is a neutralization reaction. An acid react with base to produce a product salt and water. Okay, it is called neutralization reaction. Once reaction gets neutralized, the reaction completed. The product never can be returned back. Clear? So these all are example for irreversible reaction. And one more important character of irreversible reaction is irreversible reactions are completed reactions. Irreversible reactions are completed reaction. Completed reaction. Completed reactions. What is the meaning? After certain period of time, the reactions completely complete. That means reactants once converted into product, the reaction going to be complete. Clear? Next, coming to there is no establishment of state of equilibrium found in irreversible reaction. Simply in irreversible reaction, equilibrium does not exist. Irreversible reaction, equilibrium, chemical equilibrium does not exist. Chemical equilibrium does not exist in irreversible reaction. Irreversible reactions. Because once product is formed, reaction completed. Reaction not proceed in both the direction. It is only proceed in unidirectional. So that equilibrium does not exist. Okay, this is information regarding irreversible reactions. Once again, I repeat, The characteristics of irreversible reaction. Irreversible reactions are takes place in only one direction. Reactants convert into products. Products never can be reacted back. Second thing, irreversible reactions are carried out in open vessels. Generally open vessel. It is carried out in open vessel. Third point, irreversible reactions are completed reactions. Completed reaction means after a certain period of time, reactants convert into product. Product never can be reacted back. That means reaction completed. Next, fourth point. In irreversible reactions, the state of equilibrium does not established or adjust. State of equilibrium does not established. Clear? So this is information regarding irreversible reactions. In the most of the natural phenomena, the natural reactions, irreversible in nature. Rusting of iron. Once iron get rusted, it never can be get back original iron again. Digestion of food. Once food digested, it never can come back original food again. Like that, any natural phenomena, the reactions in generally irreversible in nature. Clear? Now coming to the reversible reactions. Coming to the reversible reactions. Reversible reactions. Here what is meant by reversible reaction? The reaction takes place in both the directions. Reversible reaction means the reaction takes place in both directions. First point, the reactions proceed or takes place in both the direction. Both directions. Both directions. That means reactants converted into product similarly products convert into reactant back. Reactant convert into product convert into reactant back. Here reactant convert into product means this is called forward reaction. Simply F for forward reaction. The products are converted into reactant back means backward reaction. Forward reaction and backward reaction. And the reaction proceed both the direction. Reactant to product into reactant back. Okay. Now, second point. In generally, reversible reactions are carried out in closed containers or closed vessels. Reversible reactions carried out in closed container. closed containers. Reversible reactions are carried out in closed container. Next, for example, as earlier we discussed now, suppose the thermal decomposition of CaCO3, calcium carbonate, here calcium carbonate crystal I heated in a closed container. Then what is your observation? CaCO3 decomposed, it produces CaO and CO2. Thermal decomposition of CaCO3 calcium carbonate, it gives CaO calcium oxide and carbon dioxide. Here in this reaction carbon dioxide gas is formed, but here no possibility of escaping the gas because the container is closed container. The container is what? Closed container. So that there is no escaping of what? Gas. Here container is closed container, no possibility of escaping of CO2. So that again the CO2 react with CaCO3, again it produces what? Same product, that is CaCO3. That means the reaction proceeds in both direction when it is carried out in closed container or closed vessel. Clear? Next, coming to the third point, reversible reactions are represented by half-headed arrows. Reversible reactions represented or denoted. Reversible reaction represented or denoted. Represented by half-headed arrows. Half-headed arrows. Half-headed arrows. Like reactant, this is the one half-headed arrow. It indicates reactant converted into product. The reaction named to be forward reaction, forward reaction. At the same time, another arrow represent from reactant to product. The arrow represent from reactant to product indicates forward reaction. Another arrow indicates from product to reactant back, what we call means backward reaction. This is called backward. Understand? So it is denoted by half-headed arrows. And very important point, very important point, in reversible reaction state of equilibrium can be established. Reversible reaction equilibrium state is established. Reversible reaction state of equilibrium, state of equilibrium. State of equilibrium can be established. State of equilibrium can be established here. Here what is meant by equilibrium? Equilibrium means both forward and backward reaction takes place with equal speeds. For example, H2 hydrogen gas react with iodine gas. It is a hydrogen gas. It is an iodine vapor or gas. Now the reaction established between these two gases, it produces hydrogen iodide. It is also exists in which state? Gaseous state only, hydrogen iodide. At the same time, hydrogen iodide also decomposed into H2 gas and iodine gas. That means reactants can combine to form product. Product can be decomposed to form reactants back. This kind of reactions are called reversible reactions. Reversible reaction proceed both directions. Those are represented by off-headed arrows. Similarly, one more example. N2 nitrogen react with hydrogen 3H2 gives rise to 2NH3. It is nothing but preparation of ammonia by Haber's process. Preparation of ammonia by Haber's process, it is also an example for reversible reaction. Reversible reaction. Okay. Even formation of NO and NO from N2 plus O2. A nitrogen gas N2 react with O2 oxygen, which are registered in which state? Gaseous state. They combine to form 2NO, nitric oxide. It is also an example for reversible reaction. Clear? So these all are example for reversible reactions. Once again I repeat the characteristics of reversible reaction. First one, reversible reactions are carried out in both directions. Second point, reversible reactions are carried out in only closed vessel. Okay. Next, third point, reversible reactions are represented by half-headed arrows. One is from reactant to product, that indicates forward reaction. Product converted into reactant back, that indicates backward reaction. Fourth point, reversible reactions are, in reversible reactions, the state of equilibrium can be established. This is very, very important point. Where we can see the state of equilibrium means the state of equilibrium can be seen in only reversible reactions. Reversible reaction. Next, one most important point, reversible reactions are never completed. Fifth point, reversible reaction never completed. Reversible reactions never completed. Never completed. Once state of equilibrium established, both the reactions carried out in equal speeds. Keep on continuously. It never can be completed. But irreversible not like that. Irreversible, once product is formed, reaction going to be completed. Thank you. I hope you all are understand, right? This is the first prior most information regarding types of reactions in a chemical equilibrium, reversible reaction and also irreversible reactions. Thank you.